Monday, August 17th, 2026. Welcome back. And today we are following up on a story that is still very much developing, because just hours after Indonesia was slammed by a devastating magnitude, 7 earthquake near Flores Island, the ground moved again, this time thousands of kilometers away on the completely opposite side of the country. A magnitude 6. 9 earthquakes struck North Sumatra on Saturday evening, rattling a region home to millions of people, and while the headline number 6, 9, sounds almost as frightening as the disaster that had already unfolded in Flores earlier that same day, the story behind this second earthquake is very different, and in some ways even more revealing about what is actually happening beneath Indonesia right now. This was not a shallow, surface-shattering rupture, like the one that killed dozens of people in Flores that same morning. This was a deep earthquake, one that occurred so far beneath the surface that its enormous energy never had the chance to fully translate into the kind of destruction we saw earlier that day. And that distinction, shallow versus deep, is exactly what we are going to break down in careful detail, because understanding it is the key to understanding why one earthquake can level a town while another of nearly identical magnitude barely makes the evening news beyond a passing alert. By the end of this video, you're going to understand exactly what happened in North Sumatra, why its depth mattered so profoundly, how it connects to the broader disaster still unfolding in Flores, what the deeper tectonic architecture beneath Indonesia actually looks like, and what this entire sequence of events tells us about the reality Indonesia lives with every single day of the year, whether the headlines are paying attention or not. Let's walk through exactly what happened, because the details here matter enormously. According to the United States Geological Survey, the magnitude 6, 9 earthquake struck at 5:54 in the evening local time on Saturday, August 15th, which corresponds to 10:54 in the morning, coordinated universal time. The epicenter was located just 7 to 15 kilometers, roughly 4 to 9 miles, north-northwest of Pematangsiantar, a city of more than 268,000 people in North Sumatra province. This earthquake happened only a matter of hours after the catastrophic Flores rupture that morning, and initial reports understandably caused alarm because, on paper, a 6. 9 is an extremely powerful earthquake. It is large enough, under the wrong conditions, to level buildings, trigger landslides, and kill hundreds or even thousands of people in a matter of seconds. But here is where the crucial detail comes in, the detail that separated this earthquake from becoming a second full-blown disaster unfolding in a single day inside the same country. This earthquake occurred at a depth of approximately 172 to 183 kilometers beneath the surface, somewhere between 107 and 114 miles down. Different monitoring agencies recorded slightly different figures, with USGS placing it around 172, 5 kilometers, and the European Mediterranean Seismological Center placing it closer to 180 kilometers. But every single measurement agrees on one central fact. This rupture happened extraordinarily deep inside the Earth, far deeper than the vast majority of earthquakes that go on to cause serious surface damage anywhere in the world. To put that depth in perspective, consider that the earthquake in Flores that same morning struck at a depth of only about 10 kilometers. The North Sumatra earthquake occurred roughly 17 times deeper than that single figure. And depth in seismology is not just a technical footnote buried in a scientific paper somewhere. It is one of the single most important factors determining whether an earthquake becomes a headline about a tragic and rising death toll, or a headline about a strong tremor that rattled nerves and windows without taking a single life. When an earthquake ruptures close to the surface, the energy has almost no distance to travel before it reaches buildings, roads, and human bodies, and it arrives concentrated, sudden, and violent. When an earthquake ruptures 170 or 180 kilometers down, that same enormous release of energy has to travel through an immense thickness of solid rock before it ever reaches anyone standing on the surface. Along that long upward journey, a significant portion of the seismic energy gets absorbed, scattered, and dampened by the surrounding rock mass. The result is that people on the surface still feel the shaking, sometimes quite distinctly and unsettlingly, but the violent, destructive punch that a shallow earthquake delivers gets spread out and softened across the sheer distance the seismic waves have to travel before reaching anyone at all. This is exactly why, despite being nearly as large in magnitude as the earthquake that devastated Flores earlier that same day, the North Sumatra earthquake produced no immediate reports of casualties and no reports of significant structural damage. USGS estimated that around 6 million people felt moderate shaking from this event, with another 7 million experiencing light shaking, and a further 24,000 feeling only weak tremors. That is an enormous number of people who felt the earth move beneath them on the very same day, yet the agency assigned this earthquake a green alert level for both shaking-related fatalities and economic losses, the lowest tier on their entire alert scale, specifically because the depth of the rupture kept the danger to human life and infrastructure remarkably low, despite the scale of the underlying release of seismic energy involved. No tsunami warning was issued for this earthquake. That too comes back directly to depth and location. Tsunamis are generated primarily by shallow earthquakes that displace the seafloor directly and abruptly, and this rupture, occurring so deep beneath land in North Sumatra rather than in a shallow offshore setting, simply did not have the physical mechanism available to displace ocean water in any meaningful or dangerous way. It's also worth noting that Indonesia's own meteorological agency, BMKG, initially reported this event somewhat differently than USGS, placing it at magnitude 6. 4, with a depth of about 163 kilometers, and locating the epicenter on land roughly 20 kilometers southeast of Simalungun. These small discrepancies between international and domestic monitoring agencies are completely normal in the immediate aftermath of a major earthquake. Different networks of seismometers, different processing algorithms, and different calibration standards routinely produce slightly different initial estimates before the data gets refined and reconciled over the following hours and days as more instruments report in and analysts cross-check the readings. What both agencies agreed on, regardless of the exact numbers each one initially published, was that this was a real, powerful, deep-focus earthquake, and that authorities needed to advise residents across North Sumatra to stay alert for potential aftershocks, even as the immediate danger from the main shock itself appeared limited compared to what had already unfolded in Flores that same morning. Now here is where this story becomes genuinely fascinating from a scientific standpoint, because understanding why an earthquake this deep even occurs in this specific location requires understanding the extraordinarily complex tectonic environment that defines the island of Sumatra as a whole. Sumatra sits directly above one of the most active subduction zones on the entire planet, the Sunda Megathrust, where the Indo-Australian plate is being forced downward and eastward beneath the Eurasian plate along a boundary stretching more than 2,000 kilometers from north to south. This is the exact same subduction system responsible for the catastrophic magnitude 9. One earthquake and tsunami of December 2004, one of the deadliest natural disasters in recorded human history, which killed approximately 230,000 people across a dozen countries bordering the Indian Ocean, with roughly 170,000 of those deaths occurring in Indonesia alone. It is also the same system that produced the magnitude 8. 6 earthquake near Nias Island in March of 2005, rupturing a 400-kilometer section of the plate boundary just months after the devastating 2004 megathrust event, almost as if the crust itself was continuing to unzip along the same fault line in stages. But subduction zones like this one do not just produce shallow earthquakes along the interface where the two plates first meet near the surface. As the descending oceanic plate continues sinking deeper and deeper into the mantle, it continues to fracture and rupture internally at tremendous depths, sometimes hundreds of kilometers beneath the surface, long after it has passed beneath the coastline and moved inland underneath the island itself. This is precisely what appears to have happened on Saturday evening. The rupture near Pematangsiantar occurred not at the shallow subduction interface where tsunamis get generated, but deep within the subducting slab of oceanic crust, as it continues its slow, grinding descent into the Earth's mantle beneath North Sumatra, more than 170 kilometers straight down beneath the feet of everyone living in that region. This kind of deep intraslab earthquake is a well-documented and relatively common feature of subduction zones around the world, and Indonesia in particular experiences them with some regularity because of just how extensively the Indo-Australian plate is being consumed beneath the archipelago along its entire length. The convergence between these two plates is not a simple head-on collision that would be relatively straightforward for geologists to model. It happens at an oblique angle, which means the plate motion has to be accommodated through a complex combination of different fault types, all working simultaneously across different depths and different structures. There is thrust faulting along the shallow subduction interface itself, the kind of faulting responsible for the 2004 megathrust and for tsunami generation in general. There is strike slip faulting along features like the enormous Great Sumatran Fault, which runs the entire length of the island from north to south and accommodates the lateral sideways component of the oblique plate motion. And then there is deep internal fracturing within the subducting slab as it sinks and bends under its own weight far beneath the surface, exactly the kind of rupture that produced Saturday evening's magnitude 6. 9 earthquake near Pematangsiantar. 3 fundamentally different mechanisms, 3 fundamentally different depth ranges, all operating simultaneously beneath the same island, all products of the same underlying tectonic collision. Sumatra's Great Sumatran Fault is itself a well-known and extensively studied source of shallower, more immediately destructive earthquakes, and comparing it to Saturday's deep event tells you almost everything you need to know about why depth matters so profoundly. In February of 2022, a magnitude 6. 2 earthquake ruptured a section of this fault system in West Sumatra at a depth of only 4 kilometers, killing 27 people, injuring 457 more, and displacing over 19,000 residents, despite being a significantly smaller earthquake in raw magnitude than Saturday's event near Pematangsiantar. That comparison alone should reshape how you think about earthquake danger. A magnitude 6, 2 earthquake at 4 kilometers deep killed dozens of people and displaced thousands. A magnitude 6. 9 earthquake at 172 kilometers deep, more than 40 times deeper, produced no reported casualties at all. The 2022 West Sumatra earthquake also revealed something else important about this region, that it ruptured a previously unidentified segment of the Great Sumatran Fault, a strand that scientists had not fully mapped before it broke, now named the Kajai or Talamau Fault. Indonesia's monitoring agency initially misattributed that rupture to a neighboring segment called the Ankola Fault, before aftershock analysis revealed the true source. That kind of discovery, an active, dangerous fault segment that nobody had properly identified until it actually ruptured and killed people, is a sobering reminder that even in one of the most studied seismic zones on the planet, the full picture of the underlying hazard is still being filled in, sometimes only after tragedy forces the correction. But it would be a serious mistake to look at the lack of casualties from Saturday's North Sumatra earthquake and conclude that this region is somehow safe, or that deep earthquakes are simply nothing worth paying attention to. The reality is more complicated and, in its own way, considerably more sobering than that simple conclusion. Deep earthquakes like this one are a direct signature of an enormously active and continuously moving subduction system working beneath the island in real time, right now, as you watch this. The fact that a slab of oceanic crust more than 170 kilometers underground is still actively fracturing and releasing energy at magnitude 6. 9 tells scientists that the broader Sunda Megathrust system remains under continuous, active tectonic stress from top to bottom, not just at the shallow interface where the most catastrophic tsunami-generating earthquakes tend to occur, but throughout the entire descending slab, all the way down into the mantle. This is a system in constant, relentless motion, a system that has produced some of the largest and deadliest earthquakes ever recorded by modern scientific instruments. And Saturday's sequence of events tells a story about just how active that system remains across its full depth range. Consider the full sequence again. A devastating shallow rupture in Flores in the early morning hours. A powerful deep rupture in North Sumatra roughly 12 hours later that same evening. And then later still, a third earthquake, a magnitude 5. 7 striking roughly 600 miles further north off the Minahasa Peninsula. 3 significant earthquakes on 3 entirely separate fault systems within a single 24-hour window across one of the largest island nations on Earth. Pematangsiantar and Flores sit nearly 2,900 kilometers apart, close to 1,800 miles, on opposite ends of the Indonesian archipelago. These earthquakes did not occur on the same fault, and they were not directly caused by one another in any simple, well-understood mechanical sense that seismologists could point to and confirm. But they are both expressions of the same underlying reality, that Indonesia sits atop one of the most tectonically active and dangerous stretches of crust anywhere on the planet. And on this particular Saturday, multiple sections of that crust, separated by thousands of kilometers and operating through completely different fault mechanisms, were all releasing accumulated stress within hours of one another. Let's return briefly to what was happening in Flores. At the same time, this deep earthquake struck North Sumatra, because the two stories were unfolding in parallel, and the contrast between them is genuinely instructive for understanding earthquake risk more broadly. By Sunday, officials confirmed that the death toll from the Flores earthquake had climbed to at least 53 people, with more than 1,300 homes damaged, over 2/3 of them severely, along with healthcare facilities, schools, and government offices across the affected provinces. Hundreds of aftershocks continued rattling the island in the hours and days following the main shock. Scores of people sustained injuries, and thousands remained displaced from their homes, according to statements from Indonesia's deputy health minister during a televised briefing. That is the human cost of a shallow, 10-kilometer deep earthquake, striking a populated coastline directly. Now hold that image next to what happened in North Sumatra just hours later that same evening, a nearly equivalent magnitude 6. 9 rupture, felt by over 11 million people across a wide swath of the province, and yet producing no confirmed casualties, and no significant structural damage whatsoever, purely because of where in the Earth's crust that tremendous amount of energy happened to be released. This is one of the most important lessons in all of seismology, and it is a lesson that deserves far more public understanding than it typically gets in casual news coverage. Magnitude alone tells you almost nothing meaningful about how dangerous an earthquake will actually turn out to be for the people living above it. Depth, distance from population centers, local soil conditions, and building construction standards often matter just as much, if not considerably more, than the raw number on the moment magnitude scale that ends up dominating a headline. Two earthquakes of nearly identical magnitude on the same day in the same country can produce wildly different human outcomes, one killing dozens and displacing thousands, the other passing largely unnoticed by anyone outside the immediate region who happened to feel it shake beneath their feet for a few uneasy seconds. This is also a good moment to talk about why Indonesia, of all places on Earth, seems to generate this kind of relentless seismic activity, event after event, year after year, without any real sign of slowing down. Indonesia is a nation of more than 270 million people, spread across roughly 17,000 islands, and it sits directly on the Pacific Ring of Fire, the horseshoe-shaped belt of fault lines and volcanic systems that wraps around the edges of the Pacific Ocean and is responsible for the overwhelming majority of the world's earthquakes and volcanic eruptions. But Indonesia's position is even more geologically complicated than most other points along that Ring of Fire, because the archipelago sits at the collision point of several major tectonic plates simultaneously: the Indo-Australian Plate, the Eurasian Plate, and the Pacific Plate, along with a collection of smaller microplates squeezed in between them, each contributing its own share of deformation and seismicity to an already crowded and stressed tectonic puzzle. In the region around Sumatra, specifically, the convergence between the Indo-Australian and Eurasian plates happens at an oblique angle rather than a direct head-on collision, and that obliquity forces the plate motion to be split and distributed across multiple different fault systems working simultaneously: the shallow subduction interface offshore, the Great Sumatran Fault running the length of the island on land, and deep intraslab fracturing within the descending plate itself, exactly the kind of rupture that produced Saturday evening's magnitude 6.9 earthquake near Pematangsiantar. Prior to the 2004 disaster, the most recent megathrust earthquakes along this same Sumatran Andaman Plate boundary occurred in 1797 at a magnitude between 8, 7 and 8, 9 in 1833 at a magnitude between 8, 9 and 9, 1, and in 1861 at a magnitude around 8. 5. Since the 2004 catastrophe, much of this more than 2,000-kilometer stretch of the Sunda Megathrust has continued rupturing in a series of large subduction zone earthquakes, most of them concentrated along the plate boundary south of Banda Aceh, including the magnitude 8. 6 Nias Island earthquake in March of 2005, which ruptured a 400-kilometer section of the boundary immediately south of the area that broke in 2004. To the east of the main subduction zone, back arc spreading in the Andaman Sea produces its own distinct zone of distributed normal and strike-slip faulting. And near Burma, the Sagaing Fault accommodates a similar strike-slip component of the region's overall oblique plate motion, much the way the Great Sumatran Fault does further south. Even the subducting Indo-Australian Plate itself is not a single, simple, uniform slab. It actually comprises two somewhat independent plates, India and Australia, moving relative to one another along a broad, actively deforming zone that produces its own seismicity hundreds of kilometers west of the main trench, a phenomenon dramatically illustrated by the April 2012 earthquake sequence off Sumatra, which included a massive magnitude 6 strike-slip event and its powerful magnitude 8, 2 companion. What all of this tells us is that the section of crust beneath Sumatra has an extraordinarily long, well-documented history of producing earthquakes across an enormous range of depths and mechanisms, from shallow, tsunami-generating megathrust ruptures capable of killing hundreds of thousands of people in a single event, to moderate shallow earthquakes along the Great Sumatran Fault, capable of leveling entire towns and displacing tens of thousands of residents, to deep intraslab earthquakes like Saturday's event that release enormous amounts of energy without necessarily producing significant surface destruction at all. Every single one of these earthquake types is a genuine ongoing expression of the same underlying tectonic engine, the continuous subduction of the Indo-Australian Plate beneath Eurasia, a process that has been running for millions of years and shows no indication of stopping or even slowing down on any timescale that matters to human beings living their lives on top of it. It's also worth placing Saturday's events within the broader context of what has been an extraordinarily active year for seismic activity, not just in Indonesia, but across the entire planet. Researchers tracking cumulative global seismic energy release found that 2025 was one of the most seismically active years in modern recorded history, with the total energy released globally by earthquakes of magnitude 5 and greater reaching levels close to triple what was recorded in 2021, a year that was already considered highly active because of a cluster of 3 separate magnitude 8 or greater earthquakes striking in rapid succession. This year has continued that trend without any sign of slowing down. Just this month, back-to-back major earthquakes struck Venezuela, registering at magnitude 7, 2 and magnitude 7. 5. Representing the strongest seismic activity the country has experienced since the year 1812. A magnitude 7, 3 struck Mexico. A magnitude 6, 3 hit north of New Zealand. Another magnitude 6, 3 reactivated a fault zone in the Philippines that had previously ruptured at magnitude 7. 8. Northern California has experienced an unusual and closely watched cluster of significant earthquakes on faults that had been historically quiet for decades. And now, within a single 24-hour window on August 15th alone, Indonesia experienced a devastating shallow magnitude. 7 earthquake near Flores that has already killed at least 53 people. A powerful, deep magnitude. 6. 9 earthquake near Pematangsiantar in North Sumatra, felt by millions but causing no reported casualties, and a further magnitude, 5. 7 earthquake off the Minahasa Peninsula, roughly 600 miles further north. 3 significant earthquakes on 3 different fault systems across one of the largest island nations on Earth within the span of a single day. None of this means that one earthquake directly triggered another across such vast distances in some simple, linear chain reaction, and responsible seismologists are always careful never to claim that kind of direct causation without solid, verifiable evidence backing it up. Earthquakes separated by thousands of kilometers along entirely different fault systems generally do not trigger one another through any well-understood physical mechanism over that kind of distance. But what scientists do broadly agree on is that the Earth's crust behaves as a genuinely interconnected system operating under continuously shifting stress, and that periods of globally elevated seismic energy release do tend to cluster together across multiple plate boundaries within compressed windows of time, for reasons that remain an active area of ongoing research and, frankly, genuine scientific debate among specialists in the field. What is not in dispute is the raw data itself. 2025 and 2026 have produced a volume and intensity of global seismic activity that stands out clearly against the historical record. And Indonesia, sitting as it does at one of the most geologically complex and active junctions on the entire planet, is experiencing that elevated activity directly, repeatedly, and in this case, within the very same day. So what should residents of North Sumatra, and more broadly, anyone living across the Indonesian archipelago, actually take away from Saturday's remarkable sequence of events? First, it's worth understanding clearly that a deep earthquake like the one that struck near Pematangsiantar, even at a substantial magnitude of 6.9, is generally far less immediately dangerous than a shallow earthquake of similar or even considerably smaller magnitude. That is not a reason to dismiss the event entirely or assume deep earthquakes carry no risk whatsoever, but it is an important and genuinely useful piece of context that helps explain why this earthquake, despite being felt by more than 11 million people across a wide area, did not produce anything close to the devastation seen in Flores earlier that same day. Authorities in the region have advised residents to remain alert for potential aftershocks, which is standard and sensible guidance following any earthquake of this magnitude, regardless of depth, because aftershock sequences can sometimes include events large enough to cause damage on their own, even when the main shock itself did not. Second, and more broadly, this entire sequence of events across a single Saturday serves as a genuinely useful, real-time illustration of just how geologically active and layered Indonesia's tectonic environment truly is. This is a country where a shallow, devastating, tsunami-triggering earthquake and a deep, largely harmless earthquake can occur on the same day, thousands of kilometers apart, on completely different fault systems, and both be entirely unsurprising to the scientists who study this region closely for a living. That is simply the tectonic reality of living in one of the most seismically active nations on Earth, a reality shaped by the ongoing subduction of an entire oceanic plate beneath the Indonesian archipelago, a process that has been running continuously for millions of years and will continue running for millions more, regardless of how any single day's headlines happen to read. For people living in North Sumatra specifically, the practical guidance remains the same as it does across any seismically active region anywhere in the world. Know the evacuation routes near your home and workplace. Keep an emergency kit stocked with water, non-perishable food, a first aid kit, a battery-powered or hand-crank radio, and copies of essential documents, sufficient to sustain your household for at least 72 hours without any outside assistance. Understand which fault systems run nearest to where you live, because Sumatra's risk profile includes not just the deep intraslab earthquakes like Saturday's event, but also the shallower and often far more immediately destructive ruptures along the Great Sumatran Fault and the offshore subduction interface, each of which behaves very differently and carries a very different level of immediate danger to anyone living nearby. And if you are in a position to support or invest in stronger building codes, retrofitting older structures, or improved regional infrastructure and emergency response planning, those investments consistently make the measurable life and death difference between an earthquake that rattles windows and unsettles nerves for a few seconds, and one that levels an entire neighborhood, exactly as we saw play out in real time across 2 different regions of the same country within a single day this weekend. As of right now, the broader situation across Indonesia remains actively developing, still very much unresolved. Rescue and recovery efforts continue in Flores, where the confirmed death toll stands at 53 and is expected to rise further as crews continue reaching remote areas that were cut off by landslides in the immediate aftermath of Saturday morning's earthquake. In North Sumatra, authorities continue monitoring for aftershocks following the magnitude 6.9 rupture near Pematangsiantar, even as initial assessments suggest the region avoided the kind of serious damage seen elsewhere in the country on that same day. And beneath all of it, whether at the shallow, tsunami-generating interface off the coast of Flores, or more than 170 kilometers down within a subducting slab beneath North Sumatra, the same enormous tectonic engine continues its slow, relentless, patient work, the ongoing subduction of the Indo-Australian plate beneath Eurasia, a process that has shaped this entire archipelago for millions of years and will continue producing earthquakes here, of every depth and every magnitude, for as long as these 2 plates continue grinding against each other far beneath the surface. If breakdowns like this, ones that actually explain the underlying science behind why one earthquake devastates a community while another of nearly identical size passes with barely a headline, are genuinely useful to you, take a moment right now to like this video and subscribe, because understanding these kinds of distinctions matters enormously for anyone trying to make real sense of the news coming out of seismically active regions like this one, rather than just reacting to a scary-sounding number. Leave a comment with your thoughts below, especially if you have any personal connection to Sumatra or Flores, because on-the-ground perspective genuinely adds real value that raw data alone simply cannot capture. And if you know anyone with family or ties to Indonesia, take a moment to share this with them, because understanding exactly what happened and exactly why the outcomes were so dramatically different in 2 parts of the same country on the very same day is exactly the kind of clarity that cuts through panic and replaces it with genuine, useful awareness. Indonesia's ground moved 3 separate times within a single day this weekend, across 3 separate fault systems, at wildly different depths, producing wildly different consequences for the people living above each one. That is simply what life looks like on top of one of the most active and complex tectonic boundaries on the entire planet, and it is a reality that is not going away anytime soon. Stay informed, stay genuinely prepared rather than merely aware, and stay with us as we continue following this story in the days ahead.